Today we'll jump into pretty much a three-part series of adding rational expressions, and what we're going to deal with today are terms that already have common denominators. So if you'll notice, simple fifth grade math, we've got common denominators here. The rule for adding any fractions is once you have common denominators, you add the numerators. So I end up with 7, keep the common denominator, and I end up with 9. So here's an algebraic expression. Two terms, again, common denominators of 9. I notice I have like terms on top, so nothing really needs to be done except adding the coefficients, or in this case, subtracting the coefficients up top. So I say 17w minus 5w is 12w over 9. And you'll see that I have nothing but multiplication left and products, so I can reduce the 12 and the 9, so this goes to 4w over 3. Again, you'll notice the common denominators are still in place, but they're a little more complicated. Once again, now that I have the common denominators, I can just add my numerators up or subtract in both these cases. The top I have 7n squared minus a 1n squared, 6n squared over 12x squared. Notice this is all multiplication, so I can go ahead and reduce this final answer once again. I know 6 goes into 6 once and then 12 twice, so I have n squared over 2x squared as my solution. Here we have a common denominator that's a binomial. Doesn't change anything as long as they are common denominators. I can add or subtract the numerators, and I have like terms up top. In this case, 4x minus 2x is 2x over x plus y. Now you'll notice I have an x in the numerator and an x in the denominator, but this x is not a factor, so I can't reduce it with the x in the numerator. This is completely simplified. We move again, two terms with common denominators. In this case up top, I notice again I have binomials. I can go ahead and subtract, but in this case this is the first time we really don't have common denominators. So what I'm left with is c squared minus 16 over c minus 4. And you'll also notice that what's left in the numerator actually factors. It's a c minus 4 multiplied by a c plus 4 all over c minus 4. And you'll notice here that I have multiplications all across, so I have like factors which I can reduce, thus giving me c plus 4 as my final solution. Now in this next example, you'll notice you have common denominators of binomials which also have squared terms in them, and you'll also notice these terms factor. Whenever I have factorable terms in my denominator, I'm going to go ahead and try to factor first. So I notice in this case that I have an x plus 3 times an x minus 3, and like I said, these were already like terms, so I'm going to be able to go ahead and add the numerators. One thing you're going to have to be conscious of is I'm subtracting two terms over here. So what I like to do is I like to rewrite the whole term as x squared minus the quantity of 6x minus 9 over that LCD, which was x plus 3x minus 3. Then what I'll do is I'll remember, hey, I've got an imaginary 1 right here that needs to be distributed through. So I have x squared minus 6x plus 9 over x plus 3 times x minus 3. And you'll notice here I have perfect squares in the beginning and the end, so this is going to factor into x minus 3 multiplied by x minus 3 over x plus 3x minus 3. These are common factors, so I get to reduce one for one. leaving me with an x minus 3 over x plus 3. Once again, you'll notice there's a 3 in the numerator and denominator. These are no longer factors because of the additions and subtractions. So this is my final solution. So now we'll move to terms that have some simple denominators that are not like. So I can't add these right off the bat. I've got to break it down into their factors. Typically what I'll do is I'll see what multiplies to 16. This is a 2 times 2 times 2 times 2. 12 is a 2 times 2 times 3. So in order to find your lowest common denominator, what you need to do is find the common terms in both. I have a 2 in both, second 2 in both. So it looks like I'm going to need these 2's specifically. I'm going to need the 3 from this term. And then I'm going to need a 4 from this other term, from the remaining two 2's. And then that should be a term that both those have in common. So in this case, I've got 4 times 4 times 3, which is 48, and that's going to be my LCD. So what I'll do, let's start again. What I like to do is I like to rewrite so that I have my common denominator lining up below my original denominators. And then I say, okay, how did I get from 12 to 48 by multiplying? Well, I multiplied 4 to the denominator, so I must multiply 4 to the numerator. To get from 16 to 48, I multiplied by 3 to the denominator, so I have to multiply by 3 to the numerator. This gets me a total of 28 and 15. Now that I have common denominators, I add across, so that's 43 over 48. Again, pretty basic problem. So let's move to a case where we have variable terms in the numerator, not so much in the denominator. I need to find a common denominator of 30 and 12. Find the factors of 30, that's 2, 3, and 5. Factors of 12 are 2, 2, and 3. Notice they have in common the 2 and the 3, but we're missing a 2 and a 5. So I need a total of 2 times 3 times that missing 2 and that missing 5. Multiply all these together, it ends up being 60. So once again, I'll start over here, say 5m over 12 minus 7m over 30. Rewrite my common denominator of 60. Going to be subtracting. How do I get from 12 to 60 by multiplying? That's a 5. And 30 to 60 by multiplying, that's a 2. Multiply across, I end up with 25m, 14m. I have common denominators. I subtract like terms in the numerators. So I have 25 minus 14m, which is 11m over 60. Now we have a situation where our denominators are not like, and they're both variables. So this is much like a situation where I had like 1/3 minus 1/5, something of that nature, where these are my denominators, there are no other factors but these two, so my LCD would be basically 15 or the multiple of the two together. Likewise here, I have a factor of m and a factor of n, so I multiply the two together to get my LCD. And what I'll do, like I've done in the prior problems, is I'll represent it twice underneath each original common denominator and say, how did I get from m to mn by multiplying? Well, I multiplied by n, so I must do that to the numerator and the denominator, which means I'm multiplying by 1, get a 2n. And in this case, I'm going from n to mn, and I multiply by m in both cases, and I get 5m. Now, I have to simplify by adding terms in the numerator. However, in this case, we don't have like terms, so I just re-represent it as 2n minus 5m over mn. You'll notice once again, here's a multiplication, this is a subtraction, so these are not factors, so nothing reduces with anything below. So here's a situation where we have two terms in the denominator that are similar but not alike. If you'll take a look over here, when we're trying to find the LCD, we have an x and an x squared, which is made up of an x and an x. So to find the lowest common denominator, I need the smallest number such that both go into. Well, I have x's in common in both terms, but I'm missing an x in this first term, so I need that extra x in my LCD. So in this case, my LCD is x squared. So let's go over and write x squared twice. And I have to say, how did I get from x to x squared by multiplying? Multiply by x. So I end up with 3x in my numerator. The denominator, those were the same, so I just rewrite the 4 and then add like terms in the numerator or subtract like terms in this case. We notice neither one are like terms, so I have 3x minus 4 over my LCD of x squared, and once again, this is not a like factor with anything in the denominator. Even though we have an x here and an x here, we have subtraction, no more reducing can take place. So in this problem, again, we have unlike denominators, except they're much more difficult in this case because we have not only numbers but many variables. So let's go over and determine what our common denominator is. From the 12, we have a 2, and a 3. We got two x's for x squared and a y. Then in our second term, I have a 2, a 5, an x, and two y's. So let's see what's common in this case. We've got 2's matching up. That's about it with the numbers, so I'm going to need 2 and a 3. And then the variables, I have an x in common and a y in common. So in this case, I'll need a remaining x and a remaining y. So my LCD is going to be made up of the 2 that's in common, the extra 2 that I need, the extra 3 that I need, and let's not forget this 5 right here, and the 5. And then I have an x in common, which I'm going to need. I need another x. The y is in common, but I need another y. So my LCD in this case is 60 x squared y squared. So underneath, I'll write 60 x squared y squared under both. And go through that process once again of saying, how do I get from 12x squared y to 60x squared y squared by multiplying 12 times 5, and then I need a y as well, which gets me a 25 ay. In the next term, I'm going to need a 6 to get from 10 to 60, and an x to get from x to x squared. So in this case, I have 18bx. I'm going to subtract. Notice there are no like terms in the numerator, so this is just 25ay minus 18bx, and that's all over 60x squared y squared. I have no common factors. This is a subtraction, one binomial term, and nothing can reduce from the top to the bottom. So this is my final solution. So now we have denominators that are different, but our numerators are a little more complicated. Clearly the LCD in this case is a 10. So what I'll do is I'll rewrite my 10 twice. I'll say, what do I need to do to get from 2 to 10? Let's multiply by 5. And in this case, I'll have to distribute the top through. So this is 10d minus 25. What do I need to do to get from 5 to 10? That's a 2. Distribute once again, so that's 2d minus 8. And because I have a subtraction of more than one term, I'll rewrite everything and say that's 10d minus 25 minus the quantity of 2d minus 8 over 10. Remember, there's that invisible 1 right here, which I need to distribute through. So this is 10d minus 25 minus 2d. Negative and negative is a positive. Add like terms, so I get 8d. And that's minus 17 over 10. You'll notice I can only reduce common factors because this is an addition. This is not a factor. So I can't reduce this 8 and this 10. This is my final solution. A little more complicated now, so I've got a monomial with several variables in the denominator and binomials up top. Let's determine our LCD. You notice on the left side I have a C and two D's. On the right side I have two C's and a D. C's in common, D's in common, but I'm going to need another D and another C. So my LCD in this case is the C, but I need another C, so that's squared, and the D, and the missing D, which is D squared. Rewrite it. And then determine how I got from my initial denominator to my new LCD by multiplying. This gets multiplied by a C. I distribute once again. Gets me C squared minus CD. This gets multiplied again. D over D. Distribute. 3 CD minus 3 D squared. I notice once again I'm subtracting more than one term. I rewrite. So I subtract the quantity of 3CD minus 3D squared. Note the invisible 1 that needs distributing. So I'll get C squared minus CD minus 3CD plus 3D squared over C squared D squared. Combine like terms, it gives me a C squared minus 4 CD plus 3D squared over C squared D squared. Now, this, you'll notice, is a trinomial, and I also noticed that there's something that multiplies to a positive 3 but adds to a negative 4. This can factor. So if I say that's C minus 3D and C minus D over C squared D squared, now I have all the possible factors that are left, but I notice there are no common factors in the numerator and denominator, so no more reducing can take place. In theory, I would take both solutions. You wouldn't really have to go further than this top guy, but if there were a common factor left, then you'd actually have to take and reduce. But in this case, we didn't once again. A couple more. So in this case, we have three terms, three different denominators. I'm going to need to find an LCD. Then you'll notice in each case that everyone is completely different, so the best way to find the LCD is just to multiply everything together. So I have a 6, A, B, and C. So I'll rewrite that under each term. Figure out what I need to multiply by. So in this case, I'm missing a 3, a B, and a C. So I distribute here. I end up with 3 ABC plus 3BC, or B squared C. In this next term, I'm missing a 2AC. I have to distribute that in. So I have 2A squared C minus 2ABC. Finally, I'm missing a 6, an A and a B. 6A and a B goes to the numerator as well, and I distribute. So that's 6AB squared minus 6ABC. Then I have to add like terms. Again, you'll note I have this negative 1 I have to distribute. So I have 3ABC plus 3B squared C minus 2A squared C plus 2ABC plus 6AB squared minus 6ABC. Add your like terms. Let's find all of our ABC terms. Here's 1, 2, and 3, which gives me a negative ABC. See if I have any B squared C terms. None. So that's plus 3B squared C. That's done. A squared C, no like terms with that. And AB squared. Looking through all that, you want to look for any common terms all the way across. And I don't think I'm going to have any. There's no GCF left, so this is our final solution. Quite a bit to do today. Here are the three problems I'd like you to go ahead and solve, and we'll discuss this more tomorrow.